Good morning. So far we have been dealing with water. So next corresponding section, water after use. Certain water after use. Certain water after use becomes wastewater. So next we have to deal with the wastewater. So far we have seen domestic water supply, industrial water supply, then irrigation. During the process of utilizing the water, consuming the water, major portion of the water, a good amount of water comes out as wastewater in so many ways, in so many forms, from so many sources, with different colors, odors, toxicity, different pH values. The contamination, as you have seen, the physical contamination, the chemical contamination, the biological contamination, the radioactive contamination, and e-waste, and even solid waste. All these things makes water after use for a specific purpose as wastewater. Similarly, because of usage of water for manufacturing processes, then using of water for commercial purposes, using of water in hospitals, heavy utilization of water in industries, plants, I mean industrial plants. Then even in agriculture, the irrigated water will become contaminated, polluted, agricultural waste. In slaughterhouses, textile industry, pulp industry, paper industry, so many, all industries, when they use water, water after the process becomes wastewater. Wastewater is of two. One is sewage. Sewage is a type of wastewater. Another is effluent. Sewage is the domestic, or from the domestic water waste. The toilet water, bathroom water. So sewage is from that. They don't come under the category of effluent. Effluent, the water let out from industries, wastewater. Effluent is other than these domestic water sources, which becomes contaminated or polluted. Except that all other things are concerned as effluent. So this wastewater cannot be discharged as they are. That will create a great health problem. The whole ecosystem will get affected. The whole land will get polluted if you discharge openly. Similarly, if you discharge it to water sources, water carriers, such as rivers, streams, lake, ponds, even ocean, if you leave them as they are from the factory of the industry, the whole system will get ruined, damaged. System will fail categorically. So we have to treat the wastewater. Wastewater has to be treated, and before treatment and after treatment, they have to conform to standards regarding their pH value, the presence of heavy metals, toxicity, all the things which we have seen in the case of water. Some additional things also will be here, such as BOD. BOD is the governing factor. Biochemical oxygen demand. Biochemical oxygen demand. BOD. Then COD, chemical oxygen demand. Chemical oxygen demand. There, with respect to the dissolved oxygen, how much dissolved oxygen is there, how much oxygen is required for decomposing the microorganisms or bacteria after retaining the waste, the sewage or the effluent for 5 days at 20 degrees Celsius. That is BOD 520. 5 days you have to keep. And the depletion in oxygen. If the BOD is more, then it is the toxicity and the pollution is more. When BOD is lesser BOD, safer the sun. Similarly, the chemical oxygen demand also. Lesser the value, safer the sun. Biological. So, wastewater characteristics are BOD, COD, then the organic load required for the treatment. Then the suspended solids. How much suspended solids it has. So as you have a process, a systematic sequential process of domestic water treatment, potable drinking water treatment, similarly you have wastewater treatment too. Here there is a possibility of we getting confused with the filtering process. The filtering process for water treatment, it is slow sand filter.
So raw water comes in, and typically your turbidity is going to be less than 10 NTU if you're using a slow sand filter. And like I said, it takes about 2 days to establish the schmutz deck on the surface of the slow sand filter. So for the first couple of days, all that water is just going to go to waste. We're not going to use that and serve it to the public. But after a couple of days, when that schmutz deck is formed, it gets a lot cleaner, and we've turned it from yellow to blue to show that the schmutz deck has been established. We now have low turbidity water going through, so we can send it to the clear well and then send it off to the distribution system. So for a slow sand filter, as its name indicates, the filtration rate is very low. It's in the range of 0.015 to 0.15 gallons per minute per square foot of filter surface area. So it's got a very, very low flow rate in relation to the surface area of the filter, and that's why it's called a slow sand filter.
And rapid sand filter. slow sand filter and rapid sand filter. Here, for wastewater, it is the trickling filter. Sometimes the filtering process may be analogous, but for potable water, if the water contaminants have to be removed, the method of filtering is either slow sand filter or rapid sand filter. Slow sand filter is used for small treatment plants, and rapid sand filter is used for townships, towns, municipalities, corporations, where you want to have the yield of filtered water more, around 1000 to 2000 liters per hour yield after filtration. In slow sand filter, you will get only 200 to 300. So here it is almost 5 times. But in slow sand filter, after the process of filtering, the disinfection intensity is less. But in a rapid sand filter, the disinfection has to be more intensive. Disinfection has to be more intensive in rapid sand filter. And the word slow means filtration will be slow. Where filtration is rapid, then in the rapid sand filter, you have to backwash because they will get clogged, scum will be formed. So you have to apply using an air compressor. There will be 2 parts in rapid sand. One is filtering, second backwashing. In slow sand filter, backwashing process is not that much involved. But in rapid sand filter, initial cost may be less, but the maintenance cost will be, if you want to compare these two. Now we have to come to wastewater. So this confusion will be always there when you refer filtering. All other things are same. The coagulation, flocculation, disinfection, primary disinfection, secondary disinfection, all other things are same. Filtering, then storing. So the effluent or the sewage. But here the treatment is not only coagulation or clarification, clarifying or clarifier. Coagulation, clarifying, clarifier, sedimentation, filtering. That filtering part in slow sand filter and rapid sand filter, unlike here, it is more biologically oriented. You have a biomass or biofilm. You use bacteria and the protozoa, like that, similar organisms, to treat the wastewater. You create an environment by which these bacteria fight with the wastewater, then the wastewater contaminants are being removed from wastewater. These bacteria will work in 2 environments, in the presence of oxygen and in the absence of oxygen. Certain bacteria will thrive in the absence of oxygen. Certain bacteria will thrive only in the presence of oxygen. So the process, the treatment which works in the presence of oxygen is called aerobic process, and which doesn't require the presence of oxygen is known as anaerobic. So there are 2 types of digestion or decomposition of this biomass. Decomposition or digestion. One is aerobic digestion, another is called the anaerobic digestion. There are 2. The septic tank. domestic, suppose we take the sewage, septic tanks, the toilet, human excreta, after flushing, along with the water goes through a pipe, gets settled in the septic tank. Sometimes you will have only one well, which is known as the leach pit. And you will have a small air vent. It is not for the supply of oxygen, to enable the flow and avoid clogging of the closet. So anaerobic bacteria thrive there in the septic tank and leach pit, and decomposition takes place because of anaerobic bacteria, the biomass. Ultimate result, methane gas, methane and carbon dioxide. These two. Sludge. In addition to the sludge, you will have methane gas and carbon dioxide. This methane gas usually is used for, can be used. Similarly, the cow dung, you have biomass digestion cylinders. You have biomass using cow dung, animal dung. You can use, you will get methane gas, which can be used as a fuel gas. Methane gas. Gobar gas, it is called here in Kerala. It's called gobar gas. Subsidized, government will give subsidy to make the biogas plants. So septic tank, we will have different chambers. Water, the sewage will first go to enter the first chamber, then goes by which the detention period will be more. So when it reaches there, the decomposition will be over and you will have only clear water, which will go to a soak pit. From the septic tank, it will go to a soak pit. From the soak pit, it can be discharged because the level permissible to have reached its permissible level by which it can be discharged to the water areas. Or it can be used for gardening, it can be used for horticulture, it can be used for agriculture, anything. In the case of effluent, this is the case, septic tank is for sewage because it is from the domestic. Then you have compost. In the domestic waste, you have compost where you will have some soil worms you will put, and you put all kitchen waste from the kitchen, you put in layers, then the worms, layers, you put some soil. After some time, these worms would have eaten all the things. There would have been a biomass formed, and that biomass is good manure for plants. It will be very good manure for plants. It's called the compost, C-O-M-P-O-S-T, compost. It's analog, it is similar to a fertilizer, a manure. So that is the way by which we will treat the kitchen waste. The industrial waste, which are effluents, you have trickling filter. One is trickling filter, where you have layer of sand, pumice, brick pieces, tile pieces, synthetic materials, plastics, and in this biofilm, organisms will be formed. They are called biofilms. And you will give a hydraulic load by spraying over that water, and an organic load. Organic load is the cost for the organic load is the cost for this biofilm. Then you will allow the effluent to the upper part of the filter bed. Then when it gets filtered, you will give a sufficient detention period from 12 hours, 24 hours, 6 days, 7 days, according to the toxicity and intensity of this BOD or COD, that much time will be given. It will be just like a trough, a hopper. Water will be filtered through that, and the sludge will be dried up, which can be used for manure. During the process of trickling filter, a layer will be formed, scum will be formed, which is known as sloughing, S-L-O-U-G-H-I-N-G, sloughing. So that has to be frequently removed. Trickling filter is an attached suspension system. Attached, you have that, it is attached. The waste comes, bacteria, microorganism, microbes, aerobics. It is an aerobic treatment. Septic tank is an anaerobic treatment. Trickling filter needs, so you will have an aeration chamber. So aeration chamber is facilitating either internally or externally using compressors to aerate the waste, the organisms. The bacteria will be active only in the presence of oxygen. So you have aeration chambers, series of aeration chambers if you want. So this aeration chamber and these microorganisms, they react with the bioreactor. That what is the bioreactor? Where the effluent will be treated and you get the sludge as well as the water, which has to be disinfected. So there will be a primary disinfection, then the coagulation, clarifying, sedimentation, then the trickling filter. Forgetting the filter, slow sand filter and rapid sand filter there. At that position, the trickling filter will come. So there is a primary disinfection, then filtering, the process will be done, all these done. Then after filtering, you will have a secondary disinfection. So there will be a primary treatment and a secondary treatment. Sometimes there will be a tertiary treatment also to reduce the BOD to nil. BOD to nil is the ideal condition. Very difficult to achieve that. So that is the case of aerobic digestion or decomposition using trickling filter. It is an attached system. Effluent and they are not mixed together. They are separate, but once the effluent comes and touches the layer of the sand, pumice, brick, charcoal, plastics, certain synthetics, where you have the organic load by which microorganisms are formed, they are attached. Then the treatment takes place. The curing takes place. In the case, another is the activated sludge process. Activated sludge process. Activate sludge. So here you mix them together. The effluent is mixed with the bacteria together. Then it, as you have the decomposition or digestion takes place, a part of the digested sludge will be again put back, a reverse sludge. Certain amount of sludge will be again put, so that the amount of activated sludge will be more. The word activated sludge means it is already in suspension and together with the effluent. So mixed, totally it is a suspended system. Activated sludge process is a suspended system, whereas trickling filter is an attached system. So you have activated sludge process. Efficiency usually for trickling filter, efficiency is more. For activated sludge process, the efficiency compared to triple is less. It is a suspended system. So activated sludge process ASP depends on mixed liquid suspended solids MLSS. Mixed liquid suspended solids. Whereas trickling filter depends on the organic load. Okay? Then you have an oxidation ditch or oxidation ponds. The huge ponds where you will discharge the effluent, and the pond will have algae, water plants. So these water plants will have a lot of oxygen to supply. So naturally, these algae which are supplying oxygen are the natural aerators, and in oxidation plant, this activation sludge process thing. Oxidation plant is nothing but a reality of activated sludge process. So these are the various wastewater treatment system for sewage as well as for effluent. So I consumed a little more time today because this part can be wound up today. And for all these things, you need a lot of space. Just see how much process are involved: coagulation, flocculation, sedimentation, activated sludge process, oxidation pond. All of them need lot of acres of land, and they have to be together also, an open space. Thank you very much. God bless.